Hello, I'm in hot water again. I saw a neat little video on YouTube where a guy was using a boost converter to heat water. And the nice thing about a boost converter is often you can't really select what heating element you want, and most heating elements are designed for 120 or 240 volts, and a boost converter is a way to take a lower solar panel voltage like 24 volts and boost it up to 80 volts. That will give you some heating. In the description there's a little example of a 625 watt Camco heater element that will fit into a propane water heater for like an RV, and with something like this you could get a couple hundred watts in, and so you'd have propane with supplemental PV water heat for a camp or something like that. So anyways, normally you have a charge controller operating off a solar panel, and during the off pulses, which are these shaded areas, you're just wasting power. So when a battery is nearly fully charged, the duty cycle of the PWM controller can go down to 50% or even less. What this does is allows you to take that upper voltage, which can be 40 volts up, around 40 volts open circuit. It'll have a power point of around 36 volts, and so this is the power that you're normally just wasting. You can use that to charge this capacitor bank. The charge controllers will often have a PWM frequency of under a couple hundred hertz, so you need a much larger capacitor bank than what you would get normally in a boost converter. This circled area there is a normal boost converter. You have a coil, a FET which shorts that out to give a boost, and a diode, and then here's your water heating element. You need some kind of voltage switch and temperature controller here. Even if you turn the boost converter off by faking it with over voltage, it will still pass through whatever panel voltage you have. So normally you'd have a switch there, so when your battery is less than fully charged, it doesn't turn on the water heater. So in any charge controller you have a regulator chip, and that generally senses about 1.2 volts. You have a voltage divider which generates that voltage. Now, like I say, it's always a low voltage, 1.2 volts, might be 2 volts, but it's always something very small. And there's a little blue pot usually that you can adjust. What you want to do is, with a voltmeter, with it operating normally, look for the pin with the lowest voltage. That will be the sense pin going into the chip. And what we do is we add this little extra circuit. This TL431 looks for a voltage of 2.5 volts. If it's above that, this turns on. If it's below that, this turns off. And these will turn on to about 1.8 to 2 volts. That's the lowest voltage you can get. So it's convenient to put like an LED here. A green one, depending on who you're getting them from, is around 2 volts. So you'd have 2 volts here and 2 volts here. So this voltage can swing from the power voltage down to about 4 volts. And with a Zener here, a 4.7, a 5.6 volt Zener, when it's below when it's 4 volts or below, this is not conducting any current, so it's not faking this out to turn off. But when the voltage is under, this voltage goes high, and sometimes if you're clever you can find that you'll have a voltage regulator on the board itself that'll be 10, 12, 15 volts. You could use that. You don't want to get too high voltages. I never want to get above 20 volts with these. Some of them are a little, can break down at more than 20 volts. So if you do have a 36 volt or 40 volt source, you want to have an 8 volt Zener to keep that from going over 8 volts. And so it's a very simple circuit. So again, the idea is to fake out a boost converter into thinking the output voltage is too high and shutting off when the voltage on the panels drops below a certain set voltage. Hope you found this interesting. Thanks for watching.